Okay, so good morning. We're going to do 4.3 today, model with formulas. And if you haven't done so already, please do the minds on for lesson 4.3. And if I forgot to tell you to change the numbers, I'd like you to change the minus 10 to 49.28 so that your numbers work out a little better. Okay, so go ahead if you haven't done the minds on already and do that, please. And I'll get back to that in a second. So today's learning goal, by the end of the lesson today, you're going to be able to rearrange formulas to isolate for a particular variable in the formula. So formulas generally have more than one variable. So a typical formula would be something like this: D equals VT, right? Distance is velocity times time. No numbers in there, just letters. And so I could ask you to isolate for V or for T, because D is isolated right now. And if you were going to isolate, say, for T, then you would have to get rid of the V that's being multiplied by the T, which means you would have to do the opposite operation and divide both sides through by the V to get rid of it on this side. Okay, so we're going to be doing the same things that we've been doing with numbers, but we're going to be doing them with the letters in a formula today. All right, let's do that minds on. So I'm going to multiply the 5.6 into the brackets here. So 5.6 times 4 is 22.4 p plus 22.4. And that's going to equal 49.28. And then I want to get rid of the 22.4 on this side. So I'm going to take 22.4p plus 22.4 minus 22.4. And that's going to equal 49.28 minus 22.4. So we subtracted 22.4 from both sides. We end up with then 22.4p on the left side, and what we have over here, just do it on my calculator here, 49.28 minus 22.4 gives us 26.88. We're going to divide both sides through by 22.4, and we end up with P equals, I believe this is going to give us 1.2. P is equal to 1.2. Now that was a little bit tricky because it's the numbers aren't so nice, so I think we definitely should be checking this one. So I'll check over here. Remember to check, you just rewrite the original equation. So 5.6 times 4p plus 4 equals 49.28. And then we're just going to sub in the 1.2. So this is 5.6 times 4 times 1.2 plus 4 equals 49.28. This is 5.6 times 4.8 plus 4 equals 49.28. Let's see if left side equals right side. 4.8 plus 4 is 8.8. And this is 5.6 times 8.8. Does that equal 49.28? Let's check. 5.6 times 8.8, 49.28 on the left side. We've got 49.28 on the right side, and we've got left side equals right side. So we know that the solution is P equals 1.2. All right, let's get started on the lesson. So a formula just describes an algebraic relationship between two or more variables. And to solve a formula, you follow the same steps as you would to solve for a particular letter in an equation. Okay, so here's an example. It says rearrange each formula to isolate the indicated variable. So the indicated variable here is y, the indicated variable here is b. So we need to solve for y. Well, we've actually got it already solved for x, right? X is equal to this, but we need to get it for y. So what we need to do here is expand the 3 into the brackets. So we end up with 3y minus 3. Now my goal is to get y by itself, so I'm going to add 3 to both sides. So there we go. Now I've got x plus 3. Oopsie, I just used the black there. X plus 3 equals 3y. These cancel each other out. So now all I need to do is get y by itself by dividing through the 3. I divide this whole side by the 3. So y ends up equaling x plus 3 over 3. Okay? Not too difficult. All right, let's try this one. We need to get b by itself. So I could get rid of the 5 here. So I have minus b plus 5. Oopsie. I'm just going to undo that. Let's start that again. All right, so I'm going to subtract 5 from both sides. So this is going to be a minus 5 is equal to minus b plus 5 and then minus 5. So I'm getting rid of the 5's here, and I'm left with minus b equals a minus 5. Can't combine those, right? And now I needed to get b by itself. This is not b, this is minus b. So I get rid of the minus by dividing through both sides by minus 1. Then again, I have to divide this whole thing by minus 1. So this ends up being b equals a minus 5 over minus 1. Now we don't typically write over minus 1 or over 1 because that's really not doing anything, right? If we divide by 1, we're not really changing anything. So in order to get rid of the 1 on the bottom, we need to put that minus up here in the top. So I'm going to put minus up here in front of the a minus 5. And that way I get rid of the 1 on the bottom. And so I end up with negative a plus 5 equals b. The other way you can think about this is you can take each term here, a, and divide it by negative 1. Well, a divided by negative 1 is negative a, and negative 5 divided by negative 1 is plus 5. Okay. All right, let's do another example. We want to isolate for v this time. So here we're going to take the plus 1 that's on this side, and we're going to move it to the other side, or we're going to subtract 1 from both sides. So this is going to be u minus 1 is equal to minus 3v plus 1, and then of course minus 1. So we've subtracted 1 from both sides, and we end up then with u minus 1 is equal to minus 3v. Alright, so far so good, but I need v by itself, which means I've got to divide both sides through by whatever's being multiplied by v, and in this case it's minus 3. And again, the whole thing gets divided by minus 3. Now this one I would say you can leave. This is going to just cancel, and we're going to get v equals. You can leave it like this. I'm okay with that. Or if you want to bring the negative up and get rid of the negative in the bottom, you can do that too. So this would be minus u plus 1 over 3. So I just brought the u up and distributed it here. Or you can leave it like this. It's your choice. Okay, how about you try D now? Just pause the video and isolate for y. Alright, so here we go. We're going to try and isolate for y. So y has 4x being added to minus 2y. So I'm going to subtract 4x on both sides to get it away from the 2y. So this is 4x minus 4x. And then we still have a minus 2y here. So this becomes 0, and we're left on this side with minus 2y. And these don't combine, right? 1 minus 4x, you can't combine those, you're just going to leave that. Now I don't have y by itself yet. I need to do what? I need to divide both sides through by that coefficient, minus 2. So this ends up becoming just y, and this is just 1 minus 4x over negative 2. Or if you really don't want the negative in the bottom, you could make this 1 minus 1, plus 4x all over positive 2. Okay, so this is just either one of these is going to be acceptable in my book. Okay. Those are not easy, and students, for whatever reason, do have difficulty rearranging formulas when they don't have any difficulty solving equations. And I think it has to do with the fact that the numbers don't combine, the letters don't combine quite often, and so you're just sort of you're not ending up with a number answer like you normally would for isolating a variable. So it does take a bit of practice, but you'll be fine, I'm sure. Alright, this one is v that we're isolating for, so we've got two things going on this side where the v is. You've got the t and you've got the 1 here that you're going to have to try and get rid of. I would do it in steps again. So let's get rid of the t on this side first by subtracting both sides by t. So we have u minus t is equal to t minus t, minus 2v plus 1. So this has the effect of getting rid of the t on this side, and we're left with u minus t, we can't combine those, is equal to minus 2v plus 1. And now we're trying to get v by itself, so let's get rid of that 1 that's on this side. So it's being added here, so we're going to subtract 1 on both sides. So this is going to be u minus t minus 1 is equal to minus 2v plus 1, and then minus 1 as well. So that is gone, and we're left with minus 2v on this side and u minus t minus 1 on this side. Alright, and last step, all we're going to do now to get v by itself is just divide through by minus 2. And again, we divide the whole thing through by minus 2. So this ends up being v equals u minus t minus 1 all over negative 2. So that would be acceptable to leave it like that in my books. Or if you don't like the negative in the bottom, distribute that negative through the top, and you would end up with negative u plus t plus 1 all over 2 is equal to v. Alright, so let's do the last one here. Harvey is training for the track team. He can run 100 meters in 20 seconds. What is Harvey's speed in meters per second? So his speed, velocity, we know that, I'm just going to write it over here. You're probably familiar with that triangle that discusses distance and velocity and time. You learn this in science. The d goes in the top, and the v and the t go in the bottom. And then what you do to figure out what the equation is distance is velocity times time. Time is distance divided by velocity, and velocity is distance divided by time. So if I have this, he can run 100 meters in 20 seconds. His velocity is distance divided by time. What is Harvey's speed in meters per second? It would be the distance is 100 meters divided by time is 20 seconds. So velocity is 5 meters per second. Okay, how far can Harvey run in 3 minutes, 180 seconds. So now we're being asked to find out how far he can run. So if I have this formula here, V equals D over T, I need to rearrange that formula. So I'm just going to start with that. Really, I want to find out how far, which is the D. So if D is being divided by T, it means then that I have to multiply by T on both sides to get rid of that T on the bottom, right? So let's do that. So I'm just going to say T times V equals T times D over T, right? So I'm just taking each side and multiplying it by T. So this ends up being TV, and this ends up being just D. So D is equal to time times velocity. And if we go back and just double check on our little triangle up here, D does equal, if I look at D and I put my marker on D, D is equal to V times T. And V times T is the same as T times V. So now I've rearranged the formula, and I can say then that the distance is the time, which is 180 seconds, times his velocity, which is 5 meters per second. So the distance is 180 times 5, which is 900. And that's meters. Therefore, Harvey can run 900 meters in 3 minutes. I'm pretty sure that's pretty fast. And then I should have put a conclusion up here. Therefore, Harvey's speed is 5 meters per second. Okay, so how long would it take Harvey to run 1,500 meters? Well, how long is your T? So if we still had the formula V equals D over T, then how long would be, all right, this one's tricky. We have to get T by itself. The way you're going to do that is by cross multiplying. So we're going to write V over 1 so that we have fractions on both sides. We're going to multiply D times 1, which is just D, and we're going to multiply V times T, which is just VT. And then we've got the T that's up in the numerator now, right? We don't have it in a denominator. And now to get T by itself, we're going to divide both sides through by V. So T is equal to D over V. All right, how long would it take Harvey to run 1,500 meters then? Well, his time is going to be his distance, which is 1,500 meters, divided by his speed, which is 5 meters per second. We don't really need to put in the units, so I'll just erase that. So this is going to be 300, and it's time, which is in seconds. So you could say, therefore, it will take Harvey 300 seconds to run. Okay, so the last example is John. He bought a new television for $540. This particular amount, $540, included a delivery charge of $120 plus taxes of 13%. And so what we need to do is determine the cost of the television before the delivery charge and the taxes. So I'm going to start by using a variable. So I'm going to say let, C represent the cost of the television before the delivery charge and the taxes. So let's see if we can figure out how this $540 came about. So that's the total amount, $540. But what we did was we took the amount of the television, the cost of the television before those things were added on, and we multiplied C by 0.13. So this is the cost of the television, whatever it was. This is the 13%. And then what happened after that was there was a delivery charge added on to that amount of $120. Does that make sense? So whatever it cost plus 13% of whatever it cost plus $120 is going to equal my $540. 13%, we have to change that 13% into a decimal and multiply it by whatever the cost of the television was. So this is the taxes, this is the TV, this is the delivery charge. Right? Okay, and then this is the total. So now I'm going to take $540. I'm going to add these two together. There's like an invisible 1 in front here. These are two like terms, so this is going to be 1.13 C plus 120. And really I want to figure out what C is, so now I'm going to subtract 120 from both sides to get C by itself on the right hand side. Okay, so I'm subtracting, that's going to give me 420 over here, 1.13 C over here. And then to get C by itself, I'm going to divide both sides through by 1.13, and I'm going to end up with C equal to 420 divided by 1.13. I get about $371.68. Let's just go with that. Therefore, it will cost $371.68 before taxes and delivery. And we can see if that's correct then by adding on the delivery and adding on the tax. So let's just check. So $371.68 plus 0.13 times $371.68 plus 120 should equal $540. So 371.68 plus 13% of 371.68 is $48.32 plus 120. Does that equal 540? So 371.68 plus 48.32 plus 120. Yeah, that's $540. So left side equals right side. So you don't have to do the check, but it's helpful if you're not quite sure if you've done the question correctly or not. Okay, that is it for the lesson. Sorry that it went on so long. Can you please do the textbook work for 4.3? Not sure what that is, but I will put it on your note. And also, before you do that, do the consolidate, please, for 4.3. Thanks.